So for today's lesson, it's going to be really easy. I just have two interactives that you're going to do. Again, one more time we're going to use this circuit builder since we can't make actual circuits from a distance, and I'm expecting you don't necessarily have resistors. So last time we talked about how if you have light bulbs and you look at the voltage drop, as you put these light bulbs in either series or parallel, we saw two relationships come out. And the first one is here in this case. Oh, that's huge. Your total voltage was equal to the voltage drop on the first light bulb plus the voltage drop on the second light bulb plus the voltage drop on your third light bulb. So, in other words, we see that your total voltage here, your 9, is equal to your 3 plus your 3 plus your 3. And then when we had them in parallel, let's go ahead and take this and rearrange it. So I should write here that this very specifically, this was when light bulbs were in series. This was your equation. Your delta V equaled the sum of the voltage drops across your light bulbs. So I'll clean that up for you a little bit for your notes. Actually, let's just go ahead and clear. Your delta V is equal to the sum of your individual voltages. So in other words, delta V equals V1 plus V2 plus ... So you can account for as many light bulbs as you have in your situation. Okay, so that again, that was in series. And we talked about how when you were in parallel, something different was happening. If I take my light bulbs and put them instead so they are in parallel, or in other words, they're parallel to one another. Let's finish that off. Then we can see here that when they are in parallel, the voltage drop across the battery as compared to each light bulb is identical. And this, of course, this is if your light bulbs are of the same size. They don't have to have the same voltage drop across them. It depends on how they're made. But when you're in parallel, your total voltage is equal to voltage 1 and equal to voltage 2, ... Oops. So, when we talk about resistors, which I had you practice with last time, we're going to look at what happens when you put your resistors in series and in parallel as well. So for this example, you're going to have these two worksheets. You're going to copy the diagram onto your interactive, onto the circuit builder itself, and you're going to place the resistors in their locations. And then you're going to do it where you place the resistors in parallel. So for this, a couple things to know. I'll do the parallel first, just because right now that is what I have the circuit set up for. I'm going to take the light bulbs out and I'm going to replace them with resistors. In the interactive then, you're going to measure the voltage drop and the current that goes through each location. Now, I do think that probably the easiest way is to go ahead and put the amp meter in these locations where the boxes are located. So to do that, that's this amp meter right here. You had one after each resistor to measure how many electrons are flowing through that line to begin with. And then there also was one before it came back to the battery, because I think hopefully it makes sense that if you add together all the electrons coming from here, plus all the electrons coming from here, plus all the electrons coming from here, as they go through this line, we expect this number of amps to be the addition of these three. So I'm going to put that last amp meter here. And we can see that if we take 0.9 plus 0.9 plus 0.9, we do get 2.7. Alright, so you'll set up your circuit, and then you'll fill in the information. And your goal will be to see if you can recognize an equation that explains how the resistance works when you're in parallel versus when you're in series. Now, if you've had Webster's class or Hendrick's class, this is something you've already learned. This is going to be just review for you. If you haven't ever been taught this before, then we're just on the path of discovery right now. And I will be teaching you then or I'll go back and I'll review with you what the equation is. And this, by the way, this is probably one of our last lessons before we take our test on this material. So just be aware that we are going to be taking your next test soon. I'll go into detail on that later. If you have any questions, let me know. But go ahead and do these two interactives, and then we'll talk more at the end of the week.